Okay, some of you have asked for a review of related rates, and so I'm going to review a basic problem, kind of a middle of the road problem, and a cone problem for you. The first problem is the ladder problem, your classic ladder problem. It says the top of a 25-foot ladder is sliding down a vertical wall at a constant rate of 3 feet per minute. When the top of the ladder is 7 feet from the ground, what is the rate of change in feet per minute of the distance between the bottom of the ladder and the wall? So, the first thing that you want to do is draw your triangle and then set up your given slots the way that we normally do to record this information. Okay, so I have drawn my triangle, and again, I like to label the vertical side Y and the horizontal side X, and sometimes I label this side Z, sometimes I label it D, whatever's working for me at the moment. It's just my habit. You can pick whatever letters you want, as long as you use them consistently. And I labeled those blanks and the blanks for my rates. And I'm going to go back through and pick out the numbers. First of all, this is a 25-foot ladder. Well, the ladder would be where the Z is, so that's 25 feet. And the ladder's not changing size, it's just sliding down. It's not getting shorter or longer, so its rate of change is 0. And it's sliding down the wall at 3 feet per minute. Well, the change on the height of the wall is over here with Y. So dy dt will be a negative 3 feet per minute because we're coming down the wall. Then when the ladder is 7 feet from the ground, that is a height of 7 right here. And then they want to know the rate of change in feet per minute of the distance between the bottom of the ladder and the wall. So that would be dx dt that we're trying to find. They did not give us x, which means you need to come over and do Pythagorean theorem to figure out what x would be. Do the Pythagorean theorem with the 25 where the z is and the 7 where the y is. And if you do it correctly, you get 24 feet. So now I have all of the parts that are given to me or that I could find using known formulas. Now, I am trying to find an equation that will relate all of this, which is, again, the Pythagorean theorem. X squared plus y squared equals z squared in my case. And I want to take the derivative of that implicitly with each variable. So, chain rule 2x dx dt. And again, a chain rule 2y dy dt. And another one to z dz dt. And as you are familiar with, I like to get rid of those 2's just because they make our numbers larger, and everything has a 2, so I can just divide by 2 everywhere and get rid of that. Then I'm ready to plug in. My x is 24. Dx dt is what we're trying to find. My y is 7, and dy dt is negative 3. Z is 25, and dz dt is 0. So over here, there's nothing I can do to simplify the 24 dx dt. 7 times negative 3 is a negative 21, and 25 times 0 is 0. I can add the 21 over and get 24 dx dt equals 21, and then divide. And reduce. So this will give me 7/8 feet per minute. You want to make sure you determine what the units were that they were using in the problem and what your final units should be. Okay, we're moving on to the second example I have, which is kind of a middle of the road. It's not standard like ones that we had done, because I don't know that we've messed with angles very much, but it's easily translated using these same ideas. So if I'm looking at the triangle shown and theta is increasing at a constant rate of 3 radians per minute, that's a d theta dt. We'll go ahead and write that down. And so it's increasing at 3 radians per minute. At what rate is x increasing? So you're wanting to find dx dt. In units per minute when x is 3 units. Now, when you look over here, you feel like you're in the last problem and you need to find this other side and call it something. You don't have to. I'll show you why in just a minute. What should come to your mind, what should also come when you look at this problem, is the trig look to it. It looks like the triangles that you solved back in geometry, basic trig stuff. You have an opposite side, hypotenuse side, so you're looking at a sine situation based on this theta here. We're going to use that in just a minute. Now, they did tell you that x equals 3, and that's something that we're going to plug in to help us in just a minute. But let's start with that sine relationship. Sine theta is x over 5, your opposite over your hypotenuse. If I just take the derivative of this, the derivative of sine is cosine. The derivative of theta is d theta dt, because I'm having to do a chain rule here. Whoops. And I'm treating, or d theta dx, excuse me. Or dt, yeah. Anyway, so treat this like 1/5 x, so you would bring down the 1/5, and the x would be the derivative, would be dx dt. Okay, so once I have that, I'm looking at what do I need? Well, I know the d theta dt is 3. I'm trying to find dx dt, so I'm not going to be able to plug that in at this moment. And then I come over here. I need the cosine of theta. Some of you would want to find theta, but you do not have to. If you plug that 3 in, and you look at that triangle as having 5 on the hypotenuse and 3 over here, you can do Pythagorean theorem and figure out that this would be 4, your adjacent side, at that split second. And so the cosine would be adjacent over hypotenuse 4/5. So you can replace this whole cosine theta with 4/5, then the d theta dt with 3. Over here you have 1/5 and dx dt. So 4/5 times 3 is 12/5. And then I want to divide by 1/5, which basically is going to flip and multiply over here. So times 5 over 1 on both sides. So this is going to cancel. The 5s are going to cancel, and I'm just going to have 12 here. So I have 12 as dx dt. The units for x are what they're just saying are units, because they didn't tell us whether it was inches or meters or what. So this is a rate, and our time is measured in minutes up here. So we're going to say units per minute. Okay, for the last problem I wanted to do a cone, because this is where we have that radius and height relationship that you have to always come up with and apply to your equation. And so when you read this, I always start by looking for the height and the radius of the figure. So this says you have an inverted cone with a height of 10 centimeters and a diameter of 10 centimeters. So I'm looking at my cone. I'm thinking the overall height is 10. Go away. The overall height is 10. And the radius would now be 5 if the diameter is 10. And so that relationship that I want to write down is that the radius is half the height, or the height is 2 times the radius. And I'll decide which way I'm going to use it once I have my problem figured out. Okay, the next sentence, before I go to the next sentence, let me say, once you have that relationship written down, you're not going to use that 10 centimeter diameter or height again. Okay, you're going to use everything after it. Now move to your next sentence. Water in the cone is evaporating so that the depth is changing at a constant rate of negative 10 or 3/10 centimeters per hour. So that's dH dt. I'm going to write that down. Negative 3/10 centimeters per hour. Find the rate of change of volume, so we're finding dV dt when h is 5 centimeters. Okay, so here's all of our given information. I'm going to go to the volume of a cone because that's what we're talking about. Volume of a cone, 1/3 pi r squared h. This is something you need to have memorized. Now, you look at this formula and you look at the given information and determine, do you need r or do you need h? Well, you're trying to find dv dt, but you have dh dt and h. That means you need to get rid of r. We're going to get rid of the r over here by replacing it with this 1/2 h from the relationship we wrote down originally. So I'm going to write 1/2 h in for that r. It will still be squared. The squared was outside of that. Then I'm going to simplify my problem. So I have 1/3 pi, 1/2 h squared will be 1/4 h squared. Bringing down that h, I can multiply the 1/3 and 1/4 and the pi and write it as pi over 12. I have h squared times h, which is h cubed. So this is a simpler looking problem than this up here, and I can easily take the derivative. So I'm going to come over here and take the derivative. Derivative of v is dv dt, and again, that's what we're trying to find. Here it's just a power rule, so 3 times pi over 12 would be pi over 4, because that would reduce, h squared, and then the derivative of the inside, because we're chain ruling it, is dh dt. Now, trying to find dv dt, I can plug everything in that I need to. I can plug in h is 5, and dh dt is -3/10. If you multiply that out, make sure you square that and get 25 first. And multiply that out and reduce, you're going to get -15 pi over 8. And you ask, what units is that? So you look, your volume over time. Volume would be centimeters cubed in this case, because it's always a unit cubed. And time in this problem is hours. So centimeters cubed per hour, and here is your classic cone problem.